All right, good morning. Happy Thursday. Happy toward the end of the week. We've got a couple more days left. Plan for today. We've got a lot going on. Today you have a bunch of assignments coming in. You have your practice problems from last week and your lab from last week, and then your practice problems from this week and your lab from this week. Your quiz will go over all of the things from both weeks. Last week was Thanksgiving and it was a shorter week, so we didn't have that with a quiz. And then the two topics from last week and this week are combined, and so all of that is combined in the quiz. And so what we have is that stuff's coming in today. What I want to talk about in class today is we're going to take some time to work through the lab, and we're going to take some time on some other questions that you might have with the practice problems. And so that's where we're headed. Also keep in mind that I have office hours today from 12:30 to 1:30. And so if there's questions you don't get answered or need some extra time on, go ahead and jump on those today as well. So I'm going to start with the lab. And the lab is dealing with a simulation of carts. And so what we're looking at is how the carts move when they collide. And so we'll do some that is elastic, some that is inelastic, and hopefully some that is explosion as well. And so we're going to just walk through it. Last class, we got through about half of the lab, a little bit more than that. And then hopefully, potentially, we can get a little bit farther in what we're doing today. So my hope is, and my goal is that if you're here and you're doing this and we're talking about it, it'll get kind of soaked into your brain a little bit, and you can be able to get that lab done and wrapped up either close to do that or by the end of the day because you have a good start on it. So the lab, if you go into Schoology, week 3, conservation of momentum, November 30th through December 4th. And if we look at assignments, we have our practice problems, lab simulation, and then you should have one quiz. There's a whole bunch of them that are there for me. So when you click on that, you have two things. First of all, you have the PDF that has the questions on it, and then you have the link for the simulation. And so the simulation looks like this. And depending on how that pops up on your iPad, it can, I'm not sharing, am I? Let's go ahead and share this. That'd be helpful, huh? I'm going to present my screen. So here's my screen. So what I'll be doing is I'll be jumping. I'm going to be jumping back and forth in a few different ways here. So you should see my board here, and there's some stuff that I'll work out on the board. And then here is the collision simulation. Cool. And so what happens with the collision simulation, when you open it on your iPad, it might be really small, but there should be a little corner there, and you can make it larger if you'd like. So that's what I'm going to do here so we can all see what's going on. Our lab simulation looks like this. We're going to go ahead and clear all of those things. Can I do that? Maybe. I'm just going to, actually, let's just do this. We'll open that back up again. Open recent. Oh, hey, it saved it. Cool. Well, I'll leave that one on because that's what we'll start with. So what we're going to do in each situation is we're going to be setting up different measurements and taking different things through with what we're doing. And so we'll start, it asks that you start with an elastic collision. At the bottom, it has elastic, inelastic, and explosion. And so each section will have a certain type of collision that you should have with it. And so we want to be intentional on what we're doing with that. And so we'll start with elastic. And so when we go to that, it's not what I was going for. When we go to that, we can go here. And the first one just asks that it's essentially you're just starting where it is. So things you can see on here, the initial velocity, you can adjust by using the arrows here. This stuff is for the red cart on the left side and the blue cart on the right side. So to start, and in your lab, it asks to start just as it is, that your initial velocity of the red cart is 5 meters per second. So that's heading to the left. The initial velocity of the blue cart is -5 meters per second. It's heading to the right. And then the masses are 1 kilogram each, and it should be highlighted for a collision that is elastic. So before the collision, those are the pieces that we have here. We have 1 kilogram and going 5 meters per second. For the red cart, blue cart is 1 kilogram, -5 meters per second. And so if we total these, we have 1 times 5 plus 1 times -5. That's not what I want. This is what I want. We would have we end up with our total momentum in the system before the collision is 0 kilogram meters per second, because the momentum that we have in the red cart is equal to the momentum that we have in the blue cart, but in an opposite direction. So those cancel each other out, and we have 0 kilograms times meters per second in the system, in the whole system before we start. So then we can, the start button is in the upper right-hand corner here. And we can press the start button. And then after, so it's elastic, we can pause it. And now the red cart is heading -5 meters per second. So it's going in the opposite direction than it was previously. And the blue cart is also going opposite what it was, and it's +5 meters per second. So I'll show that again. Start it. And they both go in opposite directions. That one's not anything that's too exciting. But what we're looking at when we're doing that is, now you can see that you have a +5 velocity here. And after the collision, it's a -5. And when we're before the collision with the blue one, it's a -5. And after, it's a +5. Either way, same thing happens for the total momentum here, is that we have 0 kilogram meters per second. So how does the momentum compare before and after? Well, it was the same. It should be the same. That's what the law of the conservation of momentum is saying, and this is helping us to kind of visualize that. They are the same. Wahoo, yay, hooray. So the total momentum in the system before is equal to the total momentum of the system after. So now, that one, they're the same carts going the same speed. They just happen to be coming at each other. And so you're not having a big change in what's happening, because your situations for each cart are pretty similar. We're going to stay on elastic collision and set the red cart to 2 kilograms. And that's the only part we're going to shift on this one. So instead of being at 1 kilogram here, we'll click on the middle, reset it. We'll click on the middle one. So now we're at 2 kilograms. It adds a little bit of a mass on there. And again, we'll have a collision that is elastic. And so it'll ask us for before and after again. So let's do that. Before the collision, now we have, do this. Oh. What just happened here? There we go. Copy this, bring this down here. Before the collision, we have a mass of 2 kilograms and on the red cart. And so I'm going to switch this to a 2 kilograms on the red cart. And then my initial velocity on the red cart here will be 5 meters per second. On the blue cart, I have 1 kilogram. And on the blue cart, I will have a -5 meters per second. So it's the same thing that we were starting with before, except the only difference is that instead of having 1 kilogram here, we've got 2 kilograms here. And so when we calculate our total momentum, it's no longer going to be 0, because 2 times 5 gives us 10, and 1 times -5 gives us -5. So 10 plus -5 gives us 5 kilogram meters per second. So I'm going to put that down here. I'm going to copy this, and then I'll switch it to a 5. 5 kilograms times meters per second. That's what we're looking at here. And pick something else. So before the collision, this is what we're starting with. Now we're going to run it, and we're going to figure out how this works here. We're going to go here. We're going to start it. And after the collision, you can see that the blue one takes off quickly and the red one goes slowly. And so I'll do that again. We'll restart it. And this happens because the red one, the momentum from the red cart transfers into the blue cart. The momentum from the blue cart transfers into the red cart, but the red cart is bigger than the blue cart, so it slows down. The blue cart is smaller than the red cart, so it speeds up, because the red cart had more momentum here. So after the collision now, the red cart's going -1.7 meters per second. So we can put that over here. Just gonna move my number here. We'll go -1.7 meters per second. I'm gonna make this all smaller. go. So negative 1.7 meters per second is how fast it's going. M2 is still going at, still 1 kilogram, but now it's going positive 8.3 meters per second. And so what we're looking at when we're doing this is that the total momentum here, and in this situation, it ends up being just because of the way it rounds, this number here for V1 is actually negative 1.6 repeating, and this here is 8.3 repeating. And when you combine your momentums, it does give you 5 kilogram times meters per second if you keep all of your decimal places. But because this is rounded, when we take 2 times negative 1.7, we get negative 3.4, and then 1 times 8.3 gives us 8.3, and when we take the 8.3 and the negative 3.4, we end up with 4.9 kilograms times meters per second. So the only reason that number is a little bit different is because of the way it's rounded. If we were to keep all of the decimals, then it would stay the same. It would just be fine. So how does it compare? They're the same, and then we can just note in there that it's different because of rounding. We can just say, oh, no. There we go. They are the same. And then we can just say rounding. So all that's saying is, yep, we see it. They're the same. It's fine. But we know that the number is a little bit different because of the way the numbers were rounded here. For the next part, it's one that we're going to calculate. And so I'm going to, you'll write it on here, but so you can see it better, I'm going to write it on my board. It says you were still on elastic collision. Red card is still 2 and 5. So red is 2 kilograms, 5 meters per second. Blue is now 3 kilograms and negative 5 meters per second. So when we go to do it, we're just going to take and switch the 3 kilograms on the blue cart. It says after they collide, the blue cart will be going at positive 3 meters per second, and we need to figure out what the velocity of the red cart will be. So I'm going to go and actually show you this part. So we have the red cart before the collision. So it's elastic. So we have M1 V1 plus M2 V2 equals, so this is before the collision, M1 V1 plus M2 V2 after the collision. And so when we put that in, we have M1 before is 2 kilograms times V1 before is 5 meters per second plus M2 before is 3 kilograms times V2 before is negative 5 meters per second. So this is what's happening before the collision. And then after the collision, the masses stay the same. So I have 2 kilograms times V1, which is what I'm looking for. I'm looking for the velocity of the red cart after the collision. Plus, we got 3 kilograms times positive 3 meters per second. So I have a lot of numbers in there. Let's combine things. Here, 2 times 5 is 10. 3 times 5 is negative 15. So 10 plus negative 15 gives me negative 5 and kilogram times meters per second will be equal to 2 kilograms times V1 plus 3 times 3 is 9 kilogram meters per second. So from here, I can take and subtract 9 kilogram meters per second from both sides. And so I have a negative 5 minus another 9. Cancel it out over here. 5 minus negative 5 minus another 9 gives me negative 14 kilogram meters per second equals 2 kilograms times V1. So I'll divide both sides by 2 kilograms. That cancels out over here. Kilograms cancel out as our unit. And when I take negative 14 divided by 2, I get that my V1 should be equal to negative 7 meters per second. So after the collision, if everything has been done correctly here, then that should be traveling at negative 7. The red cart should be traveling at negative 7 meters per second. So if you want to screenshot it, I'll leave this up here just for a moment. Come on, if it'll clear the bottom there. There we go. So if you want to screenshot that, you can. This will be in the, you'll put this on the paper. There's a smaller spot than what I can write in order for you to see it. Do not just put your screenshot of this on the bottom. That's my work, not yours. I still want you to do it and think about it. But we can go back to the simulation now and we can check it. So we'll reset it. Everything was the same except we're going up to 3 kilograms on the blue cart. And so before we're at 5 meters per second and negative 5 meters per second, as we have here. After the collision, we can watch it. It collides. And you can see that the red cart took off at negative 7 meters per second and the blue cart at 3 meters per second, which was given in the problem. And so I'll do that again. I'll show it again. They collide. The red cart moves faster. The blue cart moves slower because of the way that momentum is conserved there. So this screenshot or this problem that we just looked at is what's going in right here. And again, you can kind of work that however you want with that. You don't have to show all the steps that I have, but some of them is helpful there. I just show them all so people can see what we're doing. Now we're going to move on to collisions that are inelastic. And so inelastic means that after the collision, they're going to stick together. And the first part asks you to set up with the same parameters that we have before, with the red cart at 2 kilograms and 5 meters per second, and the blue cart at 3 kilograms and negative 5 meters per second. So we're going to go ahead and put this in here. Just move this in here, make this longer so I can just type. So M1 is still 2 kilograms. V1 is 5 meters per second. M2 is 3 kilograms. And V2 is negative 5 meters per second. So we're setting that up, and then it asks about our total momentum here. So the total momentum before the collision for this situation is we have our 2 times 5 is 10. And 3 times negative 5 is negative 15. And so negative 15 and 10 combined gives us a total momentum of negative 5 kilograms times meters per second. So I'll move this here. Got negative 5 kilogram meters per second. So that's our total momentum before the collision. Assumption would be, and we're just going to, we won't do that yet, is that should be the same total momentum after. But let's find out. After we have our MT is our total mass. And so the total mass is just the sum of these two. So 2 kilograms plus 3 kilograms gives us 5 kilograms for our total mass. So we have 5 kilograms for our total mass, and we'll move that over here. And we'll watch it, and we'll see what happens with our total velocity after. Oh, I used VT on these. We got rid of that a few years ago because it was super confusing. So we'll go ahead and we have these set, but we're moving it to a collision that is inelastic. So 2 and 3, negative 5 and 5. And so after the collision, they stick together and they're moving at negative 1 meters per second. And so we can take and, sorry, wrong thing. We can take and put that in our stuff here. Do add text, negative 1 meter per second. And so if we look at our total momentum after the collision, we take our mass times our velocity. So 5 times negative 1, again, gives us negative 5 kilograms times meters per second. You can stick that there. So they should be the same. They should always be the same before and after. The only time they won't be is if you have a rounding issue, and then they'll probably be a decimal off. How does it compare before and after? They are the same. Go ahead and copy that, paste that. Now we're going to shift it a little bit. We'll keep it at inelastic. Red cart is 2 kilograms and 5 meters per second. That's what it currently is. The blue cart is 1 kilogram and negative 5 meters per second. So we will be switching the mass of that cart. We're going to go to 1 kilogram. So I'll reset it. Everything stays the same. I'm just moving this to 1 kilogram. So now it says, the right thing. Select inelastic on the bottom. We did that. There's our measurements. We've got 2 kilograms and 1 kilogram. And we want to solve for the final velocity after the collision. So I'm going to go back to my board now. And we know that the red cart was 2 kilograms and 5 meters per second. Blue cart is 1 kilogram and negative 5 meters per second. And the collision is inelastic. And so we will have m1v1 plus m2v2 equals mt times our velocity after the collision. And so this information gives us m1 and v1, or sorry, m1 v1, m2 v2, and then our total mass is adding the two up, so it's 3 kilograms. So we can put our numbers in there. We can say 2 kilograms times 5 meters per second plus 1 kilogram times negative 5 meters per second equals our total mass. Remember, when we're dealing with total mass, we're just adding them up. So 2 plus 1 is 3. And so we have 3 kilograms times the velocity after the collision. So 2 times 5 is 10. 1 times negative 5 is negative 5. And so 10 plus negative 5 gives us 5 kilogram meters per second equals 3 kilograms times V. To solve for V, we'll divide both sides by 3 kilograms. So we cancel the 3 kilograms out on this side, leaving us with just V. Cancel out the units of kilograms here. 5 divided by 3 is 1.6 repeating, so we'll say 1.67 meters per second equals V. In the simulation, it rounds to 1 decimal, so they will just say 1.7 meters per second is what it should look like as a confirmation of what we're doing. If you want to screenshot this, I'll leave this up here for a moment, and then we'll go back to the simulation and we'll take a look at it. Yeah, we're going to go back to the simulation here. So we have 1 kilogram, 2 kilograms, yep, 5 and negative 5, inelastic. So we'll go ahead and do this. It starts at 5 and 5. Afterward, they stick together and they're moving at 1.7 meters per second. So momentum has been conserved in what we're doing here. So if you look at your lab sheet, this that we were just doing and talking about on the board is what goes in here. Again, you should be writing it out or typing it out or something. It should not just be a screenshot of my work. That's not what we're doing here. All right, last one of our inelastic collisions here. We're looking at select inelastic, red cart to 2 kilograms and 6 meters per second. So we'll be changing the velocity of that red cart. And it says the blue cart will go to 3 kilograms, and after calculate the velocity of the blue cart that you would need in order for the total velocity to be 0 after the collision. And so we've got 3 kilograms here, and we're going to solve for V2 so that our velocity after the collision is 0. And so we're gonna, yeah.
I missed out on the screenshot part for the one right above the question. So
I literally just erased it. I'm so sorry. But it'll later today, after this video renders in Google, I'll put it up on YouTube so you can have it and you can take a look at it there.
All right, thank you.
Yeah. So on this next part, on this one, we're setting up and we're looking for what our V2 is. And so when we're doing this, let's go here. We're starting off with 2 kilograms and 6 meters per second for the red one. And so we'll have to shift that. The blue one is 3 kilograms. We're solving for V2 so that afterward, this is going at 0. And so because this will be moving at 0, 0 times anything is 0. So it will give us a total momentum of 0. To solve this, I'm going to move this momentum over to the other side by saying minus m2 v2 minus m2 v2. And so it gives me this rearrangement of m1 v1 equals negative m2 v2. And so now we can put our numbers in with what we're doing here. And we have 2 kilograms times 6 meters per second equals negative 3 kilograms times V2. And we're looking at, so essentially in order to have it cancel out, the momentum here has to equal the momentum here. And so, except they'll be in opposite directions. And so when that happens, if they cancel out, when they hit, there shouldn't be any momentum left because they're stuck together. And so 2 times, well, we can take and solve to get V2 on its own. We can divide by negative 3 kilograms. And so we'll have 2 times 6 is 12. Divided by negative 3 would give us negative 4. Our kilograms cancel out, leaving us with just meters per second. And so that will equal our V2 after the collision, or sorry, before the collision, in order to get no velocity after the collision. So if you want to screenshot that, you're welcome to do that, and then we'll test it together. We're in this class until 11:30, correct? 11:35, cool. We can do a little bit on the, we're moving a little bit better than in second hour today. So here's what we have here. When we go and set up that collision, we have, now we're at 2 kilograms and 6 meters per second. Set it 6 meters per second. We're going to be at 3 kilograms here, and we want to set that at negative 4 meters per second. So here we're at 2 kilograms, here we're at 3 kilograms, here we're at 6 meters per second, and here we're at negative 4 meters per second. And the goal here, based on our calculations, is that when those two collide and stick together, that their momentums cancel out and we have 0 velocity. So let's see. Yep, we got it. So that's just looking at what's actually happening when it's showing what our calculations are trying to get at here. And this, this can definitely happen if you think about, like a car crash. If you think about football players, if they both just come at each other and just like, and they're just kind of in a deadlock right there, nobody's moving anywhere. It's because the momentums are equaling out. I want to get you set up a little bit on the back side of that. So this is the calculation for this bottom part. I'm going to show it one more time if you missed that screenshot. And then we're going to look at the next part. I'll just get you set up on that. So if you needed that last screenshot before I erase it, it's right here for the bottom part of the inelastic equations. And then I'm going to go on to set up the explosion stuff. So I'm going to go back to here. Nope, I'm going to go back to here. For the explosions, it says you'll select explosion at the bottom. Set the red cart to 1 kilogram, 0 meters per second, and the blue cart to 2 kilograms, 0 meters per second. Start the simulation, record the velocities after the collision. So in this case, it's an explosion, and calculate the total momentum before and after. So to start, we're not having it move at all. We're going to reset this. We're going to be in explosion mode. So you'll see that in between here. We're going to start with our 0 and 0 here. And it said that our masses should be 1 kilogram on the red cart and 2 kilograms on the blue cart. So go ahead, go 1 kilogram on the red cart, 2 kilograms on the blue cart. So just conceptually, before we do this, because this one has a larger mass, it should be moving slower. If it has a larger mass, it should have a lower velocity. This one has a smaller mass, so it should have a higher velocity. And because this is twice the mass, the red one should actually be twice the velocity. So let's see what happens. Well, little firecracker pushes them apart. And we have our, I'll go ahead and reset that. We'll do it again. Push them apart, and you can see that the red cart is moving at negative 10 meters per second. The blue cart is moving at 5 meters per second. And so we can go and put those in what we have here. So our total velocity, or our total mass to start, move this over here. Our total mass to start was 1 plus 2 is 3 kilograms. Our total velocity was 0. Nothing was moving anywhere. And then after the collision, mass 1 had 1 kilogram. And it was moving at 10 meters per second. Mass 2 had 2 kilograms and was moving at negative 5 meters per second. And so the total momentum to start was 3 times 0. So we had 0 kilograms times meters per second. And then after, 0 kilogram times meters per second. Let's move that up here. And then after, if we have 1 times 10 is 10, 2 times negative 5 is negative 10. And when you combine both of those, you also have 0 kilogram meters per second. So now you'll set up and do something similar. On both of these, you'll stay with an explosion. You'll set the red cart to 1 kilogram, 5 meters per second, blue cart to 3 kilograms, 5 meters per second, and you'll set it up like you did. Let's do the bottom one here. So you'll go back and do that one that's in the middle there, but let's do the bottom one here so I can talk you through it, and then we'll move on to talking about some other practice problems. So it says set the red cart to 2 kilograms, 5 meters per second. We'll set the blue cart to 3 kilograms, 5 meters per second. And after this, so we're going to have them both, they're both going to be moving at 5 meters per second before the explosion. After they separate, the red cart stops. So V1 will be 0. And then V2 is what we'll be calculating. So remember, with an explosion, we have, and let's go over here. With an explosion, we have MT times V equals M1V1 plus M2V2. So what we normally have is it's almost always starting from rest. In this one, because you can visualize it, we actually have it moving to start. So MT is 2 plus 3, so our total mass is 5 kilograms. And our total velocity to start is 5 meters per second. They're stuck together and they're each moving at 5 meters per second. So 5 meters per second. They just have it separate in the way that it's set up, but they are moving together at 5 meters per second, and that total mass is 5 kilograms. After the collision, it says that V1 stops, that the red cart is going to stop. So we'll have 0 plus M2 of 3 kilograms, and we'll solve for V2 here. So because we have the 0 here, 0 plus anything is that, we can take that out. And to solve for that second velocity, after the collision, we'll divide both sides by 3 kilograms. And I know this can be hard to visualize. That's why we're doing it with a simulation here. So 25, so 5 times 5 is 25 divided by 3 gives us 8 points. If we divide 5, we take 5 times 5, we have 25. Divided by 3, our kilograms as a unit cancels out. And after that, it should be 8.3 meters per second should equal V2. So it might be negative. We'll see. We'll see if it's positive or negative on this. So let's look at that simulation here. We have an explosion. Our mass is here. We've got 2 kilograms and 3 kilograms. And we're going to go up to 5 meters per second. See how when I move it, it moves both of them? It's because they're stuck together. So we're going to go ahead and start this. They're moving at 5 meters per second. After the collision, the red one stops, and all of the momentum that was found in both of those together is now transferred into the blue one, and the blue one takes off at 8.3 meters per second. So I'll go back to that screen if you want to screenshot that. That's for the bottom part. We skipped the middle part of the explosion section. You'll do that one independently. And then the bottom part is this part. When it comes to the setting up your own, you don't have to go through and do all these kinds of equations and calculations. You're just setting up what's happening before. You're doing it. You're seeing what's happening after. You're showing that they should be the same calculation. And the biggest thing I want you to get out of that part is just visualizing what's occurring in those situations. So set it up however you want, as long as that collision can occur, and you can get those before and afters on that. So sometime today, wrap that up. It shouldn't take you real long. We got through a lot of it right now, but wrap that up and get that submitted. In the last bit of time, I want to talk about some of the practice problems. One of them that comes up quite a bit is number 4. And so I want to start with that one on your practice problems, number 4. It's the one with the fish. And the one with the fish, you've got a big fish. And this big fish is 5 kilograms. And you have a small fish. Small fish doesn't know what's about to happen. Small fish isn't going to like it. But the small fish is 0.5 kilograms. And
What's that?
in
Can
part,
we go to the other screen? I'm
say it
bad to
again.
interrupt. Can we go to the screen with the like with the words and stuff with the where you were putting the blue writing on there?
Oh, yeah. This
Yeah.
part, did you have a question about it?
Yeah, I just want to see that top part real quick.
Oh, sure. There you go. You got it?
Mm-hmm. Thank you.
Yeah, absolutely. So now the other part that I'm going to look at is the practice problems. And the part I'm looking at right now is number 4. Number 4 is talking about 2 fish. You have a 5 kilogram fish, so a big fish, swimming 2.5 meters per second. It's hungry. And it's about to eat a smaller fish. That smaller fish is 0.5 kilograms. And it's currently at rest. So for part A, it says how fast is the 5 kilogram fish moving after eating the smaller fish. And so this collision is inelastic. It's inelastic because afterward they stick together. Unfortunate for the big fish, or for the little fish. But what happens is big fish eats the small fish. So we have M1V1 plus M2V2 equals MT times V. And so M1 is 5 kilograms. V1 is 2.5 meters per second. M2 is 0.5, but V2 is 0, so this whole thing goes to 0, equals MT, so 5 plus 0.5, we have 5.5 kilograms, times our new velocity, which we don't know about. So to solve for this and to get the velocity, conceptually, we know that because the fish will have more mass, that the velocity should go down. So we'll see by how much. We're going to divide both sides by 5.5 kilograms. And so our new velocity, when we take 5 times 2.5, is 12.5. And then divided by 5.5, that's the new mass with the smaller fish in the belly of the bigger fish. And we end up with a velocity of 2.272727. So we'll just say 2.27 meters per second. And that's what's left after. That's how fast the bigger fish is going. So it was going 2.5 meters per second. Oh, it got the smaller fish. It made it slow down just a little bit to 2.27 meters per second, moving forward from there. In the next part of that question, I'm going to erase this in a moment. So in the next part of that question, instead of being at rest, the fish is swimming toward the big fish. The little fish is swimming toward the big fish. And so I'm going to erase this.
Did you order it, Mama? Mm-hmm. What's in it?
And so now it's going at 2.0 meters per second, and it's swimming toward the big fish. So we have MT times V is what we are going to have, what we're going to solve for in the end with the V. But what we have here, we can put these numbers in. So now instead of this being 0, it will actually have a momentum. And so we'll have M1 is 5 kilograms times V1 of 2.5 meters per second plus M2 is 0.5 kilograms times V2 of negative 2.0 meters per second. And that will equal our total mass, which will still be 5.5 kilograms times our new velocity. So we'll divide both sides by the 5.5. And we'll be left with our velocity. So 5 times 2.5 gives us 12.5. I'll keep units off just for a moment. 0.5 times negative 2 gives us negative 1.0. and then divided by 5.5. So we have 12.5 plus negative 1.0 gives us 11.5 kilograms times meters per second divided by 5.5 kilograms. Kilograms as a unit cancel out. And we can say 11.5 divided by 5.5, and we end up with 2.090909. We'll say 2.09 meters per second. So in the first situation where the fish was, where the small fish was at rest, when the big fish got it, it dropped to 2.2 something, I don't remember. And then in this one, because the small fish was coming toward it, it drops down to 2.09 meters per second. And so the parts we wanted to look at here, one, what was the difference between having something at rest and having something moving, and then two, how that carried out into the overall situation. So here's the top part of that. If you want to take a screenshot of that, you're welcome to. And then I will slide it up in just a moment. Slide this up. That's on there. So the things that you need to do, we are very quickly coming to the end of our time here today. The things you need to do, your practice problems and labs need to come in both from last week and this week if you haven't turned those in yet. You'll need to work on your quiz and get your quiz taken care of. Next week we just have a test, and so we'll have our review and our test for that. We won't have any new information. On Monday, I'll go through just sort of a recap of everything that we've looked at, kind of go through the equations, the concepts, give some big picture ideas of what's going on, talk about a few ways that you can prepare well for doing the test, and then you'll have the review to work on during the week. You'll take the test sometime next Thursday, and then during class on Thursday, I'll go through any review questions people might have after you've done some work in that, recap anything that you might need, and keep moving forward. We are moving forward really well. We have, after this week, we have next week, the next week, and then 2 days. And so then we'll be at winter break. So for us, we have our test next week. We have a project the next week. And then we have sort of a fun day on that last day before break. So I'll hang on here for a couple of moments if you have any other questions. We just went through a ton of stuff. If you missed part of it, I will put up this video later today, and then you can double check it and make sure you have the things that you need. So thanks for working. Thanks for moving forward. Thanks for all you're doing. You guys are awesome, and have a great day. We'll see you later.
Thanks, Ms. Edwell.
Thank you. See you later.
Thanks.
Thank you.
Thank you.